Assalamualaikum. So today our group will present about biomechanics in starting 100 meter sprinting. Okay. So 100 meter dash is a sprint race in track and field competition. As we know, it is the one of the most popular events in sport of athletics. Okay. So sprinting is a term used to show the effort in running which related to the intensity. So the speed of athletes in the starting could be slow because of the improper technique. So athletes need to understand the optimal technique and biomechanics to gain a faster run. The athlete will study or investigate and use their experience in 100 meter running to increase or improve their performance. So the better the technique being applied, the greater speed will be. So today we will investigate on how the correct technique will improve the performance in 100 meter sprint. So let's check it out.
Hello everyone, my name is Muhammad GHAZALI. I'm going to present about lateral pace and anterior pace in starting position. So when the referee say on your mark, your face must look at the finishing line so you can clear your mind and you can set a goal from this position. You must finish the running, not facing down. That's the wrong technique. So your knee don't bend too much to get stability. For the joint, we use ball and socket, hinge, condylite, and plane. So for the muscle from this position, we can see we use quadricep, bicep, gastrocnemius. Okay, for the anterior pace, you can see the hand of athlete and non-athlete. You must straighten your hand because all your weight is on your hand. If you bend, you cannot generate more power. It will be difficult when you want to push yourself.
So my name is Muhammad Adib AZRI bin JASNINATA. Okay, from the posterior view, we can see the different angle at the shoulder, which the athlete have a better angle at 215 degree and non-athlete at 228 degree. So the athlete he relax the shoulder so him not stress the shoulder and arms, while the non-athlete, we can see that he bend the shoulder inside, that will cause him compress the chest and shoulder, and it will affect their performance.
Assalamualaikum. My name is Muhammad AMIRUL bin AZMI. So today I will explain about phase 2. From here, you transition into the get set position. With this position, you are essentially setting yourself up for an explosive forward movement. So this is from lateral view of phase 2. Joint involved in this phase is gliding, hinge, ball and socket, and saddle. On the left picture is the athlete, and then on the right is non-athlete. As you can see, the body posture of the athlete is 194 degree, and then for the non-athlete is 213 degrees. So we can see that posture of the non-athlete is slightly bent, and it's not good for the starting. Next is muscle involved is quadricep, bicep, hamstring, gastrocnemius, gluteus. The arm is extension and the leg is flexion. For the anterior view, the athlete come out with 113 degree, which make the athlete more stable before starting the launch phase. The non-athlete come out with 93 degree, which is narrow and hard for the athlete to stabilize before starting the launch phase. For the posterior view, the athlete fully extend and straighten the hand at the 181 degree to have a better position for the athlete to start swing after sprinting. The non-athlete is straighten the hand at 178 degree, which is slightly bent and not good for the starting. Finally, as you hear the word get set, you need to make following transition. First, your hip should rise slowly. Your shoulder should remain in the same position, and then push your whole foot back against the block, and front leg should be angled at 90 to 100 degree. For the back leg, you should be angled at 120 to 135 degree, and your eye should remain looking down at the track.
My name is Muhammad Ismail bin Abdul MUTALIB. Hi, Assalamualaikum. Now I will present for the phase 3, which is launch phase. Now I will go through with the lateral view first. So at this phase, we can see the joint that include is ball and socket at shoulder to swing your arms, and hinge joint to make a right angle at elbow and make a large step when run at knee. So as you can see from this phase, the angle for the athlete make a good lunge is 114 degrees when make a striding, compared to the non-athletes, which is the non-athletes only make a 76 degrees when make a stride. So for 76 degrees is not the best angle to make a good stride. The stride length can help keep you going stronger, faster, and better protect from many common injuries. So that's why the stride is important when we do the lunge phase. At this picture, we can see the muscle that involved in athlete and non-athlete during the lunge phase, such as quadricep, hamstring, rectus abdominis, gluteus, and soleus. If you have prepared your muscle readily, it will help the athlete generate more force to push off the starting block and increase the speed and acceleration to continue their running, and plus the right technique to avoid get injury. The other point in this slide is comparison between arm swing when lunge phase, the athlete and non-athlete. The non-athlete not swing their arm correctly like the athlete do, so it will affect the speed and acceleration when the non-athlete continue their running. Now we move to the anterior view. So as you can see, the joint that involved in this view is same like the lateral view. So at this view we can see the comparison angle of space between left and right leg, the athlete and non-athlete when do the strike. For the athlete, the angle space between his left and right leg is 61 degrees, while for the non-athlete is 24 degrees. In our investigation, the athlete get the angle for he get easier when he start to strike, because his leg is not too close between left and right leg. Compared to the non-athlete, his leg is too close and it will be difficult to make a strike. At this slide, we can see the muscle that I point in this space, which is bicep, quadricep and gastrocnemius. As we know, every athlete will prepare their muscle readily to increase their performance and avoid the injury when perform the activity. We also can see the movement that performed by the athlete and non-athlete, which is the flexion and extension at their arm when they swing and their leg when they strike. Okay, that's all from me. Thank you.
Hi, my name is Razin AZULAN. For the posterior view in phase 3, we can see that they both use the same joint, which is ball and socket, hinge and condyloid joint. The only difference that we can see from the posterior view between them is the angle of their arms and their body, and also they also have slightly different in between their knees. Okay, so first let's see the angle of their arms and their body. The non-athlete has higher angle compared to the athlete, which is 44 degrees, while the athlete has only 15 degrees. In sprinting, the higher the angle of the arms and the body, the harder for you to maintain your body posture while running and to maintain your balance. So the athlete has advantage to keep the body balance and maintain the body posture, and he can produce high velocity while sprinting. Next, the difference is the knee. You can see that the non-athlete knee, he keep a little bit inside, so that it makes him harder to go for the next step on his right foot, while the athlete has a composed body, so he can go faster for the next step. In conclusion, after we make an analysis of the kinetic and kinematic between athlete and non-athlete, we can conclude that the right technique plays an important role in this event. Applying the right technique can make us become more faster and less risk to get injury. We have realized that the athlete has shown a faster starting speed than the non-athlete. It is because the athlete has shown a proper technique in performing the starting skill in 100 meter sprint. In addition, the athlete had a faster result because a proper technique will assist the performer to produce higher amount of force and maintain the high velocity while sprinting in the race. So that's all from us. Thank you.